In our video for today, we are going to solve a maxima-minima problem. Now we have a 3-meter statue that stands on top of a 4-meter pedestal whose base is on a level ground. Now we have to first illustrate this. So we have our statue. This is 3 meters in height, and then this is standing on a pedestal which is 4 meters high. And so the question goes, how far should a man stand from the base such that the angle subtended by the statue at the eyes of the man would be maximum? So here we have a person looking at the statue. It is mentioned that the man's eyes are 1.5 meters above the ground. So let's indicate that we have this one. So we can draw a straight line from the man's eyes going here. Now, the angle subtended by the statue at the eyes of the man refers to the angular measure formed at the man's eyes by two imaginary lines that extend from his eyes to the top and bottom of the statue. So, going here and also going here. So, we have this line and another line. Now, this angle right here at the center, this would be the subtended angle. So, this is what we are trying to maximize. So we can label this as, let's say, theta. Now notice here that if the man moves, the angle subtended by the statue at the man's eyes will change. This angle is different from the first configuration. Now moving this further, we would have this figure. And so let's try to analyze the problem using this figure. Now again, we are trying to maximize this angle. Now let's first define this distance. This is where the man is standing, and then going to the base, this is at a distance x. This is still unknown. And so let's also label this distance. So this would be 4 minus 1.5. So 4 minus 1.5, that gives us 2.5. So this is the height from the man's eyes going to the top of the pedestal. And then from this point, going to the top part of the statue, this would be 5.5. Now this comes from 3 plus 2.5. This is our height. And then let's label the angles we need. So let's say this total angle is alpha. And then this smaller angle is beta. While this one, the one we are trying to maximize, the angle subtended by the statue at the eyes of the man, this would be theta. Now notice that we could consider this triangle right here. Now it's always best to identify the angles we could form to develop equations based on them. Now, using this triangle right here, and then applying the tangent relation, which is opposite over adjacent, the opposite side to this reference angle alpha would be this distance. This is 5.5 meters. And then our adjacent side to the reference angle is x. That's the base of this triangle. So we would have here tangent alpha equals 5.5 opposite side divided by the adjacent side. And so let's start to look for another triangle we can form. Now we actually have this one. This is another triangle for which the height is 2.5 and the base is x. And so by the tangent relation, we have tangent of beta equals the opposite side 2.5 divided by the base, which is x. So we have this equation. Now, looking at the figure, the angle alpha is equal to beta plus theta. Now we have this equation here. However, since we want to maximize the angle theta, it's best for us to isolate it. So we would have theta equals alpha minus beta. So you can just move this one here. So alpha minus beta equals theta. But then, since we need the numerical values of the angles, we need to obtain alpha and beta by taking the arctangent of both sides for the following equations. And so for alpha, we have arctangent of 5.5 divided by x. Then for beta, we have arctangent of 2.5 divided by x. And so we can rewrite this function as theta equals arctangent of 5.5 divided by x minus arctangent of 2.5 divided by x. So this is now what we are trying to differentiate. Next, since we want to maximize the angle theta by determining the distance x where the man should stand from the base, we need to differentiate theta with respect to x. This is so we can find the value of x where the angle is maximum. Now, differentiating theta with respect to x, we need to take the derivatives of the two expressions here. But before that, let us recall our rule for inverse trigonometric functions. Now, this is what we need to do. We have to differentiate these functions, and then our rule for that is the derivative of arctan of a function u. This would be u prime divided by 1 plus u squared. Now, u prime here is present to complete the chain rule. And so our u is what's inside the function of arctangent. Therefore, for the first term, what's inside is 5.5 divided by x. That will act as our u. So this is our u, and then we can rewrite that as 5.5 times x to the negative 1. Now, since x is our denominator, we can bring it up and then change the sign of the exponent. So this is now negative 1. Now, we are rewriting this so that we can differentiate easily. So we would have negative 1 times 5.5, that would be negative 5.5. And then x to the negative 1, let's subtract 1 from the exponent. Negative 1 minus 1, that would be negative 2. Therefore, our derivative would be negative 5.5x to the negative 2. But we can bring it down. Since x to the negative 2, we have a negative exponent, we can bring it down. So this would be negative 5.5 divided by x squared. And so this is our u prime. We can substitute it here. And so applying the same process for the second term, we would have u equals 2.5 over x. And then our derivative, or u prime, is negative 2.5 divided by x squared. And then substituting the values of u prime and u to this equation, we would have the following. This is the derivative of the first term, this one. And then for the second term, we have this one. And so we can substitute this to our original equation. So these two, bring them here. So we would have the following function. Now d theta divided by dx, let's just substitute the derivatives of these terms. We would have this one. Now we still have a lot of terms on our denominator. Now to clean this up, we first have to notice that in the denominator, we could square this term. Now this is a fraction, so we have to square the numerator and the denominator. So we would have this one. This now becomes 5.5 squared divided by x squared, and the other one becomes 2.5 squared divided by x squared. And the next, we could multiply x squared, these two, to this expression and also this one. Now what would happen is x squared times 1, that becomes x squared, but multiplying x squared to the second term, that will cancel x squared. So we would have this one. Again, this will cancel, and also this one. We are essentially distributing x squared. However, don't forget to set d theta over dx to 0, since we want to identify the point along the function where the slope is a horizontal line, or 0. Now that's where our angle would be maximum. Now to further simplify this, we can multiply the two expressions by the product of these two terms, the terms in the denominator. Now this is because the product of these two terms would be our common denominator. And so we would have this one. Multiplying this expression by the common denominator, we can multiply this to the first term. Now multiplying that, this will cancel. And then what would be left is this expression right here. However, for the second term, multiplying this whole expression to the second term, this will cancel. And then we are left with this expression. And so essentially, we would have 0 equals negative 5.5 times x squared plus 2.5 squared. And then negative times negative, that will become positive. And then we have 2.5 times x squared plus 5.5 squared. Now again, this has already cancelled, and also this one. And so they are replaced by these terms. And so we can finish solving this by expanding the following terms. So let's copy it, and then distributing negative 5.5 and 2.5, we would have the following. Now, negative 5.5 times x squared, we have this term. And then negative 5.5 multiplied by 2.5 squared, it would give us negative 34.375. And then 2.5 times x squared, it would be this term, while 2.5 multiplied by 5.5 squared, this would give us 75.625. And so we have here 0 equals, joining the like terms, negative 5.5 plus 2.5, they have a common term x squared, so we can just add them. So this would give us negative 3x squared, and then negative 34.375 plus 75.625, they are both constant terms, so we can add them. This would give us 41.25. Now moving this to the other side of the equation, we have 3x squared equals 41.25. And so dividing the two sides by 3, we have x squared equals 41.25 divided by 3. And then this is equal to 13.75. Therefore, taking the square root of the two sides, then we would have x equals square root of 13.75, which is approximately 3.708099244. Now this is in meters. So this is where the man should stand from the base to maximize the viewing angle. So this would be our answer. 3.71 meters approximately. Just an additional input, if you are tasked to solve theta, this angle, just use this distance and then substitute this to the original equation, which is this one. So you would have here theta equals arctangent of 5.5 divided by square root of 13.75, which is our value of x, minus the arctangent of 2.5 divided by square root of 13.75. Now plugging this in, this would give us theta equals 22.02 degrees approximately. Now if you want to check your answer using a graphing calculator, I could show it to you by using the Desmos site. Now in order to graph the function, we have to go back to our original equation, which is this function for theta. Now we can input this into our graphing calculator, and then let's try to check at what distance x will the angle be maximum. So we can model it here. We have theta. This will act as our function y essentially. So we can just input arctangent, click this one, and then we have our functions. So arctangent of 5.5 over x, we need a fraction, so this one, and then divided by x, and then minus arctangent, functions, arctangent, fraction, then we have 2.5 divided by x. So notice here that we have our trough and summits at the following points. So this would be the distance. Notice that this is our maximum point, 3.7081, which is the same as our answer. This one, 3.708. And then the angle here is 0.3844. Notice that this is different from 22.02. Now this is because when graphing, we have to use radians for our units. Now to obtain this value, you can just use, let's multiply this 0.3844. Let's convert this into angle. So multiply this by 180 degrees divided by pi radians. So press equals, we have the following value. So this would further prove our answer. Now again, since this point is the maximum point, the slope here of the tangent line is horizontal or 0. That's why we are trying to set the slope to 0 to find the maximum or minimum point. And so I hope you have learned something from this, and that you could apply them for your future quizzes and exams. So once again, thank you for listening.